Welcome back to physics. This video is the one that you will want to watch if you want help on the cat and mouse Gizmo activity. The purpose of this activity is to kind of wrap our knowledge full circle around how we can determine the speed of an object looking at a distance versus time graph. Now, a couple things that you need to remember about distance versus time graphs. First thing, time is always and forever going to be on the x-axis. Distance will forever and always be on the y-axis. We can use the slope of the line to help us determine the speed. Remember, one of the ways that we can do that is just to eyeball the steepness of the line. Look at the slope. If it's a steep slope, the object is moving relatively fast. If it's a shallow, kind of laid flat slope, the object is moving kind of slow, right? We can also do some calculations to help us determine the speed. So we can look at how much distance the object had traveled in a certain amount of time and use the speed equation to calculate the speed of the object. One last thing with distance time graphs that we talked about before was the y-intercept. Remember, that's where the line actually crosses over the y-axis. In terms of speed and position and things like that, the y-intercept represents an object's head start. So they're not starting from the origin 0, they're starting ahead of that origin. So the y-intercept tells us how far ahead are they. All right, knowing that, what I would like for you to do right now is pause this video and go answer the prior knowledge questions number 1 and 2. I'll give you 3 seconds to do that and we'll meet back in 3 seconds. All right, hopefully you pressed pause and got those questions done. Now we can go ahead and go into the Gizmo warm-up questions. A couple things that I want to point out to you about the Gizmo. We have 3 different things that we can manipulate or change. Starting with the blue stuff. Anything blue is going to deal with the mouse. So notice that we have the ability to change where the mouse has its head start. We can also change the mouse's speed. Right? So I can slide this left and right. I can give the mouse a very short or small head start. I can give the mouse a very large head start. I can also change the speed so that the mouse runs relatively slow, or I can also change it so that the mouse runs relatively fast. Now, again, I said everything blue is the mouse. So notice that on the graph here, the blue line represents the mouse's movement. I was like, what is that word? The mouse's motion. There it is. Down below in the simulation, if you press this simulate button, then you can actually see the characters moving. And again, the blue guy is the little mouse, right? Now, the red is dealing with the cat. And the only thing that we can change about the cat is the cat's speed. So again, if I slide this slider to the left, the cat's speed slows down. If I slide it to the right, then it speeds up. I can do everything in between. That's the only thing I can change about the cat. On the graph, the red line is the cat. And notice that that red line will forever and always start at the origin 0. It's only the mouse that can have a head start. Again, in the simulation, if I was to click the simulate button, the red guy was running across there. That is the cat. All right. Now, again, go ahead and press pause, and I'd like you to go and answer questions 1, 2, and 3, where you get to kind of press some of those buttons, press simulate, and see what happens, all right? So count to 3 seconds, go pause, work on those, and then come back. All right, welcome back. Hopefully you actually pressed pause and got those questions done. We are going to go through activity A together. The first thing that we have to do is get the Gizmo ready. So notice it says click refresh in your browser to completely refresh the Gizmo. Make sure that you do that. I'll give you a couple seconds to do it. And also so I can have a coffee break, because that's important to me. All right, let's see what it says. It says experiment with the settings for the mouse head start, mouse speed, and the cat speed. For each simulation, match the settings in the table below and then click simulate to determine whether the cat actually captured the mouse and when the capture occurred. If the mouse escapes, leave the last column blank. All right, so look at this table here. Each of these columns represents one of the variables that we can manipulate. So for mouse head start in the first row, we want to set that to 1 meter. So take your slider, scoot it over to 1 meter. The mouse speed, we want to be 5 meters per second. So I'm going to bump this up a little bit. There we go. And then for the cat speed, I also want it at 5 meters per second. Looking at how it is right now, it's already at 5. So with those settings in place, I want to determine, is the mouse captured and when was the mouse captured? I can click simulate to see this scenario play out. So I'm looking and I'm observing, and it looks like the mouse makes it. The cat does not catch the mouse. So is the mouse captured? You would type no right there, and we're going to leave this last column blank. Let's move on to the next one. Click reset on your simulation. The next scenario says the head start is going to be at 5 meters. So the mouse gets a 5-meter head start. The mouse is running at 2 meters per second, so relatively slow. And the cat is running at 3.5 meters. All right. Go ahead and run simulate. Run, 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 run. All right. The mouse has been caught. So for the second scenario, you will type yes. And then for the time of the capture, how would we figure out the time of the capture? You're going to have to look at your graph. All right. Now take a look very closely. The mouse and the cat are running towards the mouse hole, and eventually you see the lines of the graph cross over each other. At that point, that is when the cat has caught up with and has crossed paths with and has caught the mouse, that blue point right there. You can click on this show whether the cat catches the mouse button, and it's going to point to it, and it lets you know that the cat has caught the mouse right there. It gives you additional information. It says the cat runs 11.67 meters in 3.33 seconds and catches the mouse. All right. Now that time, 3.33 seconds, that is the amount of time that it took for the cat to catch the mouse. So the time of capture is at 3.33 seconds. I will type this one out for you just so you can see it as an example. All right, now you are going to do the remaining 3 scenarios. This one, and then you get to choose your own. It should not be the same as these other ones. Choose your own, and then fill out the last 2 columns, all right? So go ahead and hit pause, and then we'll come back and we'll do parts A through H together, all right? Go do some questions. Is that awkward for you guys, or is it fine? I don't know. You'll let me know later. Okay, so let's go ahead and talk about A through H. Question A, what is represented by the y-intercept of the blue line? Blue line, if we're looking at this graph here, where it crosses over the y-axis. Remember we had set the head start to 5 meters, and that line crosses over the y-axis at 5 meters? That represents the head start of the mouse. What does the slope of the blue line represent? Well, remember when we changed the mouse's speed left and right? Well, we set it at 2, which means the slope of this line is 2. And that tells us that the speed of the mouse is 2 meters per second. What about the slope of the red line? Again, we set the slope of the red line to be 3.5. That tells us that the cat is traveling at a speed of 3.5 meters per second. Part D, what do the blue and red dots represent when you press simulate? Now, in case you missed it, we can rerun the simulation and you'll see blue dots and red dots appear on the graph. So just be very observant of those dots compared to the motion in the simulation. Did you notice how the dots matched the exact position of each animal as they were traveling, towards the mouse hole? Those blue and red dots represent the positions of the animals as the mouse is getting caught. Okay, part E. In each situation where the cat catches the mouse, what is true about the graph? If we have a graph like the one shown here, how do we know where the mouse was how do we know if the mouse is going to get caught? like just by looking at the graph, if we didn't have the simulation, we just had the graph, how would we know that the mouse was caught? What would we specifically look at? Put that as your answer for part E. In part F, in each situation where the cat was not caught, what is true about the graph? Or you can think about it, what do we not see in our graph that lets us know the mouse was free and able to run away from the cat? Whatever you're thinking, put that down for part F. For part G, what do the coordinates of the green dot or the intersection point tell you? Again, that's this blue dot right here. I know they say green. I don't know where the green comes in. Maybe if I hit reset. Oh, there it is. Look at that green dot. There it is. What does that tell us? That green dot. There's a couple different things that we can learn from it. Remember, each point corresponds to a time and a distance. What does the time represent? What does the distance represent? Part H. If the cat runs faster than the mouse, will it always catch the mouse? Now, this one you might have to do a little bit of experimenting with the simulation on the Gizmo to see if that's the case. If the cat always runs faster, will it always catch the mouse? Do your best to come up with that. Whatever you decide, make sure that you explain and back up your answer. All right. We're going to move on to number 2. Take a quick 10-second mental break, stretch, do whatever you need to do. All right, for number 2, we're going to be looking at this graph here on the Google Doc. So I'm going to make my screen just a little bit bigger and zoomed in. Let's see if we can go even bigger. There it goes. Number 2, it says the graph at the right depicts a cat chasing a mouse. The lines show the positions of the animals or the distance from the cat's starting point over time. The mouse is trying to reach its hole, which is 20 meters away. So that makes sense. Let's take a look at the graph, right? The blue line represents the mouse. The red line represents the cat. The cat is starting at 0 meters. The mouse is starting at, looks like 6 meters. And the hole that the mouse is trying to get to is 20 meters away, which is the very tip top of this graph. All right. Answer some questions based on the graph. Questions you're going to be answering. The cat always starts at a position of 0 meters. Where does the mouse always start? Again, you should be looking at the y-intercept of that blue line. Part B, where is each animal after 1 second? You're going to want to look for a specific distance. How far has that animal traveled? So looking at 1 second on the time, go up until you hit the cat's line. What distance are they at? Go up until you hit the blue line. What distance is the mouse at? Part C, what is the speed of each animal? Be sure to include units on your answers. Hint, don't forget to factor in the mouse's starting position. So here's what I like to do when I'm calculating the speed of an animal using a graph. We know that speed is going to be measured in meters per second. So I want to ask myself, well, how far can that animal travel in 1 second? So let's find an interval of 1 second. So let's start with the cat. The cat starts at 0, and 1 second later, what position was the cat at? The cat had traveled to 6 meters. So for the cat's speed is 6 meters in 1 second, or you could say 6 meters per second. For the mouse, though, we want to figure out how far did the mouse travel in 1 second. But we have to consider that the mouse had a head start, not like the cat. So the mouse had a starting position at 6. 1 second later, it was at 10 meters. So what's the difference between 6 and 10? Well, that's a difference of 4 meters. So the mouse's speed is 4 meters per second. Part D, the slope of the line is equal to the change in y over the change in x, meaning the rise, how much distance was covered, over how much time had it passed. It says, what are the slope of the 2 lines shown in the graph? My hint to you is that they should be very similar to the speeds that you calculated in part C. All right, part E. Did the cat catch the mouse? If so, at what time? So remember, when we look at a graph, how do we know if the cat has caught the mouse? And using that specific point, what time did that occur at? And that would be your answer for when the cat caught the mouse. Okay, pause the video right now. Go do some of those questions. I'm going to take another sip of coffee and then we'll finish this activity up. All right, the very last one. This one I would like for you guys to try and do on your own. What I do want to help you with is kind of reading through some of these numbers here. So it says a mouse is 5 meters in front of a cat, which means it has a head start of 5 meters. It is 15 meters from its hole. Don't worry about that number. That is not something that you can change or manipulate on your graph. The only one you can change is the fact that the mouse has a head start of 5 meters. The mouse runs at a speed of 4 meters per second. That you need to change on your little slider things. The cat runs 5 meters per second. That you can change, and we'll need to move the slider to the correct position. Then you will see the graphs. Okay, listen carefully. This is how you edit one of these pictures here. When you click on the graph picture, it's going to have a button down below that says edit. Click edit. You'll want to zoom in here so that it's a little bit easier to see where your lines need to go. So you can click zoom. Let's make it like 100. And let's make it even bigger, like 200. That looks good. All right. Whatever graph you see in your Gizmo, you want to recreate that on your drawing. So you can use this line tool. Just click the button. If the cat starts at the origin, for example, and it's going 5 meters per second, it probably looks something like this. And you want it to be the same color. You want it to be red. So go up here, click the red button. You can make it a little bit bolder if you want, and then you're good. All right, that's for the cat. Now for the mouse, you'll want to do the same thing. Click the line. I'm just going to put some weird line in here just to show you how to do it. Oh no, don't move the graph. We want a line. Okay. And then same thing, we want it to match what's being shown on our graph in the Gizmo. So we want it to be blue. We can make it a little bit wider. And there you go. Oops, delete that one. When you think you have your graph done and set, then you just click save and close, and your graph should show up with its nice pretty lines, and it looks great. All right. Once you have that, go ahead and answer questions A and B, and then you should be good to go. Hopefully this video helped you. If it didn't, email me, come to office hours, set up a my conference time, whatever floats your boat. Be prepared for more graphing practice in the afternoon time. We'll see you later.